dude, you gotta go for like the biggest swing version of this. Go as fast as you can towards the best vision of this. 100% at that point, like believed he could do it. And I was just like, look, I'm going to help you raise some money and find other people that are willing to invest as well. So that's the story. I mean, I can't emphasize enough, like how many questions I asked to get to the point where I could even have this conversation. But once I sort of understood what the value was and what is it specifically that needs to be done and stuff, it's hard to stop thinking about it because it's like so transformative.
I'm very excited to talk to both of you guys. Eli, I had the pleasure of meeting you at, is that a Foresight conference, I think, in San Francisco?
Yeah, that's right.
Yeah. And I've been reading your stuff for a long time and love it. And Ethan and I had met previous to you guys meeting. And then I found out you two were working together. So this is a really like great excuse to have you on the podcast, share what I learned from Ethan, and just like bring the knowledge of batteries that you guys are working on to the world. So Eli, are you cool with maybe starting with a little quick background of yourself and introduction?
Sure. Absolutely. So I am Eli Dourado. I'm a senior research fellow at the Center for Growth and Opportunity. I also just really love helping early stage startups get going. And so I work on a little bit. I have a small syndicate a very low volume syndicate that I run and try to work with hard tech founders to get their businesses off the ground and do awesome things in the world, which is what I want to see.
Nice. Yeah, that's I love I think your pinned tweet is like just a rant of like all the futuristic things that you want to see built. And I hope we can do an episode
absolutely.
On maybe like each one of those things over time. I think batteries are on that list, aren't they?
Yeah, totally. They may not be actually. So like I kind of was sleeping on batteries until I met Ethan and started talking to him about what exactly could we do if we had much denser batteries.
Yeah. So let's do a quick intro for you, Ethan, and then we'll get into the good stuff.
Yeah, sounds good. So Ethan Loosbrock, I founded a company called Ouros. The main thrust of Ouros is that I believe we can get to batteries that are 10x the energy density of existing batteries. And so one of the linchpins of that is sort of a new cathode chemistry we're working on. And my background, I studied chemical engineering at the University of Minnesota. I worked at a couple startups, Solid Energy Systems and Polyjoule. And then I spent about a year at MIT doing cathode research and really worked closely with Professor Ju Lee at MIT. And that was, I think, formational in shaping some of my views on batteries and really inspiring some of the main thrust of Ouros.
Yeah. All right. So let's start with dessert and see like why are batteries so important? Like Eli, what did you wake up to in the last little bit that Ethan might have opened your eyes to?
Well, there's so much that changes when batteries become denser. So first of all, like batteries become cheaper when they become denser. So if you look at there's some research by a guy named, I think, Micah Ziegler, who kind of looked at what determines the cost of what has contributed to the cost of declining battery costs over the past 30 years or so. And he finds that charge density is like the number one factor in sort of reducing the cost. So if we want to keep driving the cost down, like we got to go after new chemistries that increase density. We're kind of right now in a world where we're like continuing to do like very incremental optimizations of basically existing known chemistries, and it's really important to unlock new ones. And so then, I mean, when you think about batteries being cheaper and denser, because it's not because they actually come together, then you can get into this wild world where your car, your electric car, first of all, like actually is cheaper than a combustion engine vehicle now because the batteries are cheaper. And then, people talk about range anxiety as being like a big obstacle to electric car adoption. Well, that goes away if you can make your car have a range that's like longer than you can drive in a day. Right. Like, so if you can get like 1,000+ miles of range, then you don't have range anxiety anymore. Nobody worries about it. It actually changes, like, you don't need as many charging stations on the highway anymore. Right. That becomes like much less important if you're never going to charge on the highway anymore, because you just charge at home or on, at the hotel or whatever, and then you just keep driving. So it completely changes cars. I spent a part of my career in aviation. I was at Boom for several years, the first policy hire leading their policy team. So I think a lot about the aviation industry, and the aviation industry is completely bottlenecked on sort of for EVTOL aircraft and other like sort of subsonic commuter planes and stuff like that on energy density, right? Like, so the number I've heard is you need like 400 watt hours per kilogram in order to make any of the math on this close. And you really, probably need a little bit more on that to make it a viable business. And so, I think if we actually want, there's this book, Where's My Flying Car? If you actually want your flying car, you need, it's a fantastic book. Yes. But if you, like one of the unlocks, one of the things that will unlock your flying car is battery density. And then I just think there's probably a million different things. So if you think about like, okay, so like Apple, I guess this is coming out in several weeks, but Apple just, I guess last week, unveiled their new headset, right? Their new VR headset. And it's like, okay, it's got 2 hours of battery life, and it's got like its external battery pack. And they didn't want to put it on your head because it weighs too much, right? That right there is like immediately, like we see like, it's the bottleneck there is battery density. Now I hope we do a lot more than just like personal computer devices and stuff like that. But I just think throughout the whole economy, there's going to be all kinds of things that are enabled by denser batteries.
Yeah, absolutely. I was just going to mention there's I think, I don't know where this project has gone, but Google at one point had a project where they were sort of trying to do some AR stuff within a contact lens. So basically having a micro battery in the lens on your eyeball. And there again, it was just like they couldn't get the good enough batteries to last long enough in a small enough format to fit there. And so that's sort of like a weird other AR application for this stuff.
I spend a lot of time also thinking about like electricity and the electricity grid and electricity markets and electricity generation and stuff like that. And a big thing that people talk about is like we need like lots more transmission, and we need to build these plants, these solar plants in the middle of the desert, and sort of pipe the electricity in to where people live and stuff. And man, I just think like if you had ultra cheap batteries, because they're denser, right? And so the same amount of materials is used, but the same like mass of materials is used, but you get a lot more power out of it. It could be trivial to put like 100 kilowatt hours of battery in like every home in America, and then all of a sudden like solar panels really become viable. Like rooftop solar becomes really viable, and you could even like disconnect everybody from the grid, like every residence that is like not an apartment building, right? If you have some rooftop and you have 100 kilowatt hours of storage, that is enough in huge swaths of the country to just completely decouple from the grid, and you don't need to be on there at all. And you save all the fight that we're having now about like how do we increase transmission on the grid, or how do we do interconnection and all this stuff. That all goes away. So it's just there's so much that it just solves, and like those people can stop fighting and they can just get back to work doing other productive things.
Well, let's hope they stop fighting. They could stop fighting. Let's see. The renewables, the renewables power shifting all gets easy. The nuclear, the like adjusting anything that's stored through nuclear. Like I think I've heard Elon talk about, like, for the electrification of the whole economy, we just need, and transition to sustainable energy, we just need massive amounts of batteries that we don't yet have. And the better they are, the fewer we're going to need.
Yeah, that's like I think an underappreciated point about higher energy density batteries is, for a given amount of storage, you have to process a given amount of materials. And if your materials hold more energy, like, you just have to process less materials. So it means like less manufacturing capacity, less plants that need to be built. Even some things as trivial as like transporting these batteries after they're made gets easier because you can fit more on a truck or on a rail car. So there's these weird like synergies where, as you go to higher and higher energy densities, it just like makes everything cheaper.
Could you explain, Ethan, a little bit about like why energy density is like the key metric for evaluating a battery's quality?
Yeah, it's sort of like encompasses all of the input. So it's, I don't know, this might be a bad reference, but some engineers will be familiar with like non-dimensional numbers, and usually these numbers are like they try to encompass all of the important parameters for, whether it's flow in a pipe or and the number gives you some like indication of the behavior of that physical system. And so for batteries, it's like, well, like, for different applications, it determines how much energy you have, but also how much weight penalty comes with that energy. And so, if you like the amount of electrons goes into it, the weight of the materials goes into it, the sort of embodied cost associated with that, making that weight of materials goes into it. And so it's just like a sort of all-encompassing metric that we use to measure like how efficient it is. And it's not even just specific to batteries. Like it's sort of usable across fuels. So there's this great book by Vaclav Smil that he just details like how, almost everything can be measured across different systems as like energy or power density. And so he looks at like, okay, how much land is needed for a given energy source, how much, the shift from like wood-based fuels to coal to oil, and basically how, as we've shifted to higher and higher energy density materials, we just get much better standards of living because things just get cheaper, performance of things gets better, and so you need to spend less time, less energy, less resources to do the things that you want to do, whether it's cooking or traveling or heating your home.
And where does energy density come from in a battery? Eli, you sort of alluded earlier to the chemistry that happens to a given mass input for a battery. And I know that's, Ethan, where you worked for a while, but can we give a sense of that? Because it feels a little like alchemy, right? Like the same amount of mass goes in, but due to the way that you process it and manufacture it and what goes in, like very different capabilities sort of come out the other side.
So maybe I should give the like sort of layman's let's take a stab at a layman's answer, and then Ethan can like tell me I've got it or I don't have it, right? And so I think the layman's answer, I think, is like, how are you actually storing the lithium ions on each side of the battery, right? Like, are you storing them? Are you kind of like not reacting them and like holding them in between, like a lattice between other stuff, or are you reacting them and making them part of an additional molecule? And it turns out if you store them in a sort of reactive way, then that enables like much higher density of those ions. And then that in turn allows you, as they move from side to side, then that allows more electrons to obviously flow across the connection points. So how did I do, Ethan? You can correct me.
Yeah, that was very good. I think the only thing I would add is, like, as you pointed out, like the electrons are stored in these reactions between lithium and other materials, and so if they're reacted, they're stable. So you can sort of imagine it as like there's a reservoir on top of a hill and a reservoir on bottom. And lithium, if you have pure lithium, it's just super reactive, and so it's not very reversible. So you can't really go back and forth. But if you have like materials on either side, then it's reversible. And so the whole idea of getting to higher energy density is like lowering the weight of these other materials that lithium reacts with in proportion to like how much lithium you have. So it's always like this ratio of like active to inactive materials, and so if you can just like minimize all of the inactive stuff and make more lithium be part of the reaction, then you'll get better batteries. And it's not specific just to lithium. Like you can use, traditionally we've had like lead acid batteries. Some people are working on sodium, potassium type batteries, but as it turns out, lithium's super light and is incredibly good for batteries because it's so light.
That was one of the things that I was excited about as I sort of started to wrap my head around your approach, is like, it's kind of staggering that we use lithium ion at basically all the scales that we were talking about, right? From like homes to cars to laptops to phones. I don't know if you remember, like, was the contact lens thing also a lithium ion battery?
Yeah, they were trying to use a lithium battery for sure. Because there's really like, beyond lithium, like if you think lithium's only like 7 atomic mass units, so there's very few elements that are lighter than that, like hydrogen and helium. But hydrogen comes with a whole host of challenges, and helium's very scarce. So luckily, like lithium, without despite all of the scaremongering, is like relatively abundant, and so like it that sort of abundance with the lightness of the metal makes it a good pick.
Like beryllium could be theoretically denser, right? Like because it's got like 2 charge units for just like 2 more atomic units, mass units. But it's it's like insanely expensive, right? And there's all kinds of like problems with like reacting it. So lithium's probably the best that we're gonna do.
Yeah, I agree. I mean, the other challenge is like, with metals that have like more than one electron, the sort of multivalent species is what those are called, and it adds like, it's sort of like orders of magnitude more complex to make systems with those, because like the first electron you put on it is easier, but the second one makes it very, very hard, and it makes it very sluggish when you're charging and discharging.
Yeah, it also builds upon the existing battery supply chain that we've got, right? So like we don't have to find rare earth minerals or synthesize any new things. It's just like an improvement of the manufacturing of the chemistry, really, piece of the manufacturing process that goes into the same kind of batteries that we're already building, that can represent this huge sort of step function in capabilities. And I think it's worth sort of highlighting how big that is. Like, Eli, maybe you are the best suited to sort of give a little bit of a history of like battery improvements historically, but this has a potential to be like a very, very big jump.
Yeah, I think that's right. It's a enormous potential. I think to riff on one of the things you mentioned in terms of like mining and acquiring minerals and stuff, like obviously, like logically, like if you're denser for the same amount of minerals, right? You're using you're reducing your dependence on mining, right? On mining new minerals. You're reducing your dependence on importing minerals from countries that could be hostile, or countries where they where there's human rights conditions you don't want to mess with, and so on. And so you're just making the whole thing much more efficient, but also just like better from a geopolitical standpoint. In terms of the improvements that we've had over the years, my understanding is like lithium ions batteries have been around for several decades in some form, and they have just sort of gradually improved over time. They sort of the industry has operated on this, sort of taking incremental steps forward and improving the chemistries and improving the, relying on materials that get cheaper, like changes in the chemistry of this sort of the mix of like the other minerals involved. So nickel, manganese, cobalt, for example, they've shifted from like 1-to-1 ratios of 1-to-1-to-1 ratios of kind of those to like 8-to-1-to-1 ratios, just to economize on cost. People have been more recently working on batteries that don't require those minerals, like lithium ferrophosphate batteries that avoid some of that mineral usage, but also come at a weight penalty. So again, they're like less dense than sort of the cutting edge lithium-ion batteries. And so I think that this space, I think there's we've kind of we're close to exhausting the gains from like sort of the traditional way of doing things in terms of just continually optimizing the process. And really, we're at a point where we do need new chemistries to be able to drive the space forward.
Yeah, I think that's 100% right. I think so. I guess John Goodenough introduced lithium cobalt oxide in 1970. It took a couple decades, and like Sony really like launched the first lithium-ion battery with graphite and lithium cobalt oxide. I don't think Sony even really recognized like how big it would be, and certainly I think Goodenough didn't really necessarily recognize it either. And it took 50 years for John Goodenough to actually receive like a Nobel Prize for his work. But I think people have really come to realize like how big it was, and to Eli's point, like, it has just been incremental stuff that they've done, and they basically swapped out, like he mentioned, different transition metals, so nickel and manganese for lithium cobalt oxide, and it's actually still like more or less the same in terms of energy density, and so a lot of the gains have just come from like scale, some manufacturing improvements, and like we're still like, as time has gone on, we've just been approaching the price of those materials since the energy density is not changing. And so if you can both use higher energy density materials and eliminate some of those costly materials that they use for existing batteries, then you can sort of introduce a new, like, shift that curve up, if you will, and give like a new parameter space to optimize. And so like, yeah, the more shifts you can do of that curve, the more applications open up for batteries. And I mean, I think batteries, like a lot of people have recognized that batteries are used in all sorts of places today that many people thought they never would be. And some of these applications didn't even exist when the first batteries were introduced. So like a lot of people have recognized the importance of how computing has advanced with Moore's law, and how instrumental that was for the introduction of something like the iPhone. But the one underappreciated advance included in the iPhone in 2007 was like how the lithium-ion battery played a central role for enabling the sort of power usage that they needed.
I think batteries have a really interesting interplay with power draw as well, right? There's a company, I think SF based, called Impulse Labs, right? And they're trying to solve for like, how do we get more induction cooktops installed, right? So right now, like I have a gas range at home, and I'd love to have an induction cooktop. But if I wanted to do that, I would have to get an electrician come out and like run a new line from my kitchen to my electrical panel, and because the power draw of those cooktops is just too high, unless you use a battery, it turns out. And so Impulse Labs, like what they're doing is they're like putting a battery on it, like letting the battery charge like when you're not using the cooktop, which is like most of the time, right? And then when you are using it, it's combining the draw from like AC and the battery, and the battery itself has like enough power draw to power the whole cooktop. If even if your power was like we're completely disconnected from the grid, so it's like you're kind of like can save on the sort of like the high power draw of batteries can like economize on like electricians needing to come out and like run new lines in your house, right? So it's like it's pretty awesome.
That's like the transmission point you made earlier, but on a micro scale.
Yeah, the more batteries, the cheaper batteries get, the more use cases expand for them, right? Like you could totally, like, why aren't refrigerators sold with like a backup battery inside that can just keep your food cold for 48 hours if the power goes out? Like that should be a relatively simple, straightforward, easy thing to do. You can imagine a router having a small battery is like keeps your Wi-Fi up for 12 hours if your power goes out. Like these are small power draw things that, like, especially as blackouts happen more and more, you don't have to power the whole home. You can, like, a lot of things will get included there. And what happens with a huge, a 5, 7, 10x step function in energy density, like batteries become the default path for so many more things. I mean, 1,000-mile range on a car is like, that's more than any gas car that isn't massively modified, right? Like that becomes a much better thing for much cheaper, like basically overnight. So I like it's easier, though still hard, to imagine all the things that could get better. It's the second order of like where all the places batteries might go if they had these capabilities that they don't today is like really, really exciting.
I think like there's other sorts of transmission that are, sort of riffing on Eli's transmission point, is like, if you both have read, Where's My Flying Car? If we end up going to sort of a default like flying car, and I think electric propulsion makes that a lot more feasible. It's a lot louder, a lot cleaner than gas options, but in that sort of world, like you maybe don't need as many roads going to all these places. Like think about all of the roads we have, especially in like rural places, that are sort of net negatives on the system, because you don't get as much economic value as you put in, and so like all of that could potentially go away if you just are flying place to place. And I think like people always think like, oh, well, these flying cars will use so much more energy. But it's not always the case, right? Like it's if you're flying point to point, the most efficient way is a straight line. And so roads are rarely made in a way where you can go in a straight line from any point to any other point. And so there's all sorts of weird things that change, and status quos that are sort of upended in that scenario.
I think like personal transportation, like e-bikes and scooters are like, it's just going to completely transform and get like so much better, right? Like there's a lot of like, we have like a bike share system here in the DC area, and like those are unpowered bicycles. But like if the batteries were not expensive, you could imagine those are all like e-bikes now, right? And then that makes like more people commute via bike, right? Like to work, right? And that like reduces congestion on the roads, and that like wear and tear on the roads, and like so like a million different second and third order effects from it being cheap. And if you go to like congested Asian city, like so many mopeds, right? Like terrible air pollution because of it. But like, what if you made those like electric, and gave if everybody could have like a super awesome moped and like get around town that way, that would be like that's a cool future that I'd love to see.
Yeah, a fully electrified city would be much closer to an urban paradise, I think. Yeah, quieter, cleaner, whisper smooth. Those are cool and efficient. Like you can build a much smaller electric vehicle than you can an internal combustion. Just like the number of moving pieces and just the total mass that has to go into it, stuff like that. We probably far surpassed the use cases that like McKinsey imagined when they were estimating battery growth rate. At Eli, that was something in your we should talk about that. How you came to the syndicate that you chose to lead for Ethan here, and like how you guys sort of got to know each other and put together. And though maybe the right place to start with that is Ethan's story. So do you want to, Ethan, you want to say like sort of how you came into this industry, like how you picked up on batteries being such an important thing and decided to kind of devote your life to this problem in this company?
Yeah, absolutely. So I guess, going way back, I was sort of an environmentalist growing up and got into engineering. I like read this magazine, Popular Science, and followed a lot of the early stuff that Elon Musk and others were doing at Tesla, and so I ended up going to University of Minnesota and picked chemical engineering because it seemed like it was like a good way to solve environmental problems on the front end rather than sort of cleaning them up afterwards. And so it seemed to me then as now that a lot of the stuff that people were trying to get to work, solar, wind, EVs, were limited by the battery. And if you look at EVs today, like a huge amount of the cost is still the battery. If you look at like solar and wind adoption, it's very limited by the cost of batteries. And so yeah, I mean, I had this internship before my senior year where, I just didn't have enough work to do. I would ask for work and it was a small company, so they just didn't have enough for me. So I decided to dive into the battery literature and see what people thought was the future. And a lot of people were talking about lithium oxygen batteries and lithium sulfur and some of these chemistries. And so, I tried to take a license for this technology my senior year at Minnesota. And, being an undergrad, Professor Lee understandably said no. So I looked for jobs at a battery startup in the Boston area, and went to Solid Energy Systems, worked on sort of lithium metal anodes there for 2 years, and just started showing up at Professor Lee's office every couple of weeks and built a relationship with him, and then ended up getting hired into his lab, where I again wanted to take this technology out. He, I think, is sort of notoriously, he's somewhat risk averse and is like really a perfectionist in the best way. Like he's the top of his field, and is like a master of many different sciences. And so he had me work on a slightly different cathode. He had me work on more of like an adaptation to an existing cathode material. And so I took that sort of from bench scale to pilot scale. And then, the COVID hit and any sort of chance of starting a company with him at that time went to zero. And so I went to Polyjoule and designed an electrolyte for them that was like 50% higher energy density and about half the cost. And so I think my skill sets have grown through these experiences, and my network has gotten a lot better. So I saw that as the opportunity to really jump in and pursue this full time. And I think the odds are much better now than they were when I was in an undergrad position. So I feel like much more confident in my ability to actually make this happen.
Yeah, it feels like I mean your vision is so compelling here, and the gains, the size of the prize is so big. If we can build, what you think we can build here, it feels like a lot of people have been rallying around this, even at really early stages, which is super exciting. And Eli's one of those people. So I want to hear the story that I haven't heard actually of you guys sort of finding each other and coming together.
Yeah, so I first heard about Ethan from Austin Vernon, a friend of mine, who was just like, hey, I was talking to this guy Ethan, and he's got really really cool battery ideas, and he's trying to start something up. You should talk to him. And so I did, and I had a call with Ethan and tried to like understand what he was doing, and sort of took me a while. I don't have an electrochemistry background, so I just sort of stayed in touch with Ethan for a while, and just like kept peppering him with questions over Twitter DMs, just like question after question, like tell me about this, and tell me about this, and sort of like he would like refer me to like some papers, and so I'd like read those papers, and then I'd ask more questions and stuff, and I was like, dude, you gotta go for like the biggest swing version of this. Go as fast as you can towards the best vision of this, and I was like, yeah, I'll I totally 100% at that point like believed he could do it, and I was just like, look, I'm going to help you do it whatever way I can, and including I'll help you raise some money, and find other people that are willing to invest as well. So yeah, that's the story. I mean, I can't emphasize enough like how many questions I asked to get to the point where I could like even have this conversation. But yeah, once I sort of understood kind of what the value was, and what is it specifically that needs to be done, and stuff. It's hard to stop thinking about it, because it's like so transformative. And I'll add, like, part of my process also is like writing about it, right? So like I most of what I do in my day job is a lot of writing, and so I think of like writing is a form of thinking, right? And so like being able to like write down a memo, articulating why what's going on here, and why is it valuable, and what's it going to change. I think that is that's a way of like actually confronting your own ignorance about what you don't know, and then it's like go back to Ethan and ask more questions, and but then when you get to the end of it, like you actually know the stuff pretty well, and you have a pretty decent view of it.
Yeah, I would second that. I think Eli's process has been incredibly diligent, and he is super detail oriented, and really like has, I think, better than almost anyone I've talked to understood like all aspects of batteries and where and applications and markets and all of that. So it's, yeah, I mean, I think credit to Eli on that.
Yeah, Ethan was laughing when Eli was like, I asked a lot of questions. He was like, yeah, it was a lot of questions. But it's a lot to wrap your head around, especially I think, Eli, you alluded to the like what needs to be done. Like it's hard. It's a lot easier to kind of understand the software development process or see a demo of a thing, and like that was a lot of what we talked about before we invested Ethan too. Is just kind of like, where are we now? Where are we trying to get? How much is it going to cost? Like, how do we underwrite some of this stuff? It's really because batteries is a scary place. And I think we can talk about why, but like there's been for some reason, a lot of like false claims or a lot of over optimism or something in the history of battery technologies. I'm sure what the right framing is there.
Yeah, I mean, I don't know. I mean, it's hard to say which. Like, there's all of there's like a spectrum of like, you know, over optimism to like something more nefarious. And I think most of this stuff starts off from like a good place, like of just like, you know, very optimistic people trying to build something better. And yeah, I mean, like there's been a lot of these ventures that have raised lots of money and you know, come to like run up against like laws of physics or other challenges, manufacturing challenges down the road. And I think batteries probably more than a lot of industries is like, probably victim to like some of the like herd-like or like lemming-like mentality with a lot of industries. And so like, there's I think there's a few buckets where there have been just enormous amounts of startups, tons of money poured. And there have been some like I would say minor successes. Like there are some like real companies that are around. But I think it just gets overshadowed by just like the size and number of failures, that are like adjacent. So, yeah, I mean, without calling attention to, you know, too many of the failures, I think there's some great companies like early on, like, you know, in the early 2000s, A123 Systems like launched. They really like brought LFP or you know, lithium iron phosphate to market, and you know, they were a legitimate company. They had a great product. They you know, they did end up going bankrupt, but not because of sort of their product being inadequate, just because of unfortunate market conditions and some of their customers going under at the wrong time. And you know, more recently, I think there's some great silicon companies, Group 14 and Sila, that have made a lot of headway. So you know, I think it is and can be a scary place, but I think you know, there's still reason to be optimistic about battery improvements.
Yeah, I think we have to be, right. Like, I mean, there's a little bit of probably a little bit of assumption that tons of resources are being poured into it, and we can't outpace the current sort of incremental improvements that we've seen historically. But it's far too important and foundational of a technology to not invest heavily in the research and commercialization and manufacturing of something, especially when you see something with sort of this potential and without really any crazy, I don't know, costs or changes. There's no crazy rare earth things. You don't have to like change the manufacturing process. We don't need any massive changes and things. Like, we still get the charging speed and are able to sort of build on everything that the whole industry has already learned about the scale that we're producing lithium-ion batteries. Like, I don't know. It's a very, it seems almost too good to be true in an area where things that have seemed too good to be true are often like, have often been claimed, but it's such an important piece. And I think, I mean, we talked a lot about the foundation of it and how many things it's an input to, but it just seems like a moral imperative to like continue to invest in batteries. And I think we're seeing that more and more. Like, more of the electrification is driving that, and the renewables investments are driving that too.
One thing that I think is really interesting is, you know, through like the Inflation Reduction Act and so on, like there's so many subsidies going into like scaling battery production. And, you know, like talking to Ethan, I'm not attributing this view to him, but like sort of like what I'm wondering now is like, is that almost like premature? Like, wouldn't it be better to scale after, like to apply all the scaling, like after we've increased like further energy density, right? So I do worry a little bit that like the battery industry is like having this like sort of premature scaling effect where we have something that like kind of works. I think it's the same thing in renewables, right? Like, we know that wind and solar work at least decently well, And so like there's a big push to like scale them. And then the thing that comes along with that is transmission. Like you do, if you're kind of trying to do a wind and solar heavy grid with current technology, like you've got to put in a lot of transmission, and that is massively contentious, as I said. And so, I think like my like sort of a meta point here is like let's get all the sort of gains on the science side and scale that, right, and sort of like not just science but like translational work, right, and if we can translate like a much better version of battery technology and then scale that, we'll be in really, really good shape. And it's not the end of the world that we're scaling batteries, because there is Ethan's turned me on to plasma recycling, so maybe we can recycle some of those batteries in different ways.
I mean, I guess there's a few companies now that are working on, like, you can basically take battery materials and like using a plasma, pretty much restore it to brand new with very little energy and cost input. And so it's like it's just like a way of like refreshing battery material. So they still do like some mechanical separation, but then you just like run it through the plasma, and then at the end of it you have like something as good as virgin like battery materials.
So once it's manufactured, it has like a much longer potential functioning life.
Yeah, pretty much. I mean, the energy input for recycling this stuff and refreshing it is a tiny fraction of what it takes to like mine and move around and manufacture things as if like from scratch. And so at the end of it, like all of the recycling will just basically reduce the amount of mining and other things we'll need to do. And then the sort of like end goal or like final system looks like you not needing to mine hardly anything at all. And then you just like have good enough battery collection services to like recycle all of this stuff. And so yeah, I mean, there's sort of like a nice feedback loops there as well that would drive down the cost of batteries, because the cost of your input materials would then just like trend towards the like energy costs needed to refresh them.
And so batteries are going to get very, very, very cheap, right? Like in this scenario, right, where we have like better chemistries and plasma recycling, it's going to get super cheap, like kind of no matter what.
Yeah,
interesting. Over what time scale do you see those happening?
I mean, like it's a hard question to answer, because it sort of depends on like what applications end up using batteries, and so we haven't even really scratched the surface on that question. And so it's yeah, I mean, it's like for cars, like the turnover period for like our fleet of cars is like 20 years. And I mean, we're not even at like 100% EV penetration yet. So this is sort of like probably multi-decadal timescales. And like aerospace like hasn't even started electrifying. So it's yeah, I think it'll take a while. But yeah. And then I think on Eli's point on scaling batteries, yeah, I agree. Like it's probably optimal to scale the right chemistries. And the point about like just getting our like sources and things in the US is good. I think there's, I don't know, like I don't think we're the only ones doing like putting our fingers on the scale. So I don't really want to make like a fairness argument, but that you could make that argument. And I think it's just like it's just going to become even more critical to have these industries in the United States. So just from a national competitiveness standpoint, like, yeah, we need to be making these batteries.
Yeah, is that where some of the policy tailwinds are coming from, Eli? Is it sort of geopolitical considerations?
Yeah, I think there's a lot of concern that we in the next several years, right, there could be at some point a Chinese invasion of Taiwan, which I don't think Taiwan is like a major battery producer, but China is, right? And so what is the U.S. response to a Chinese invasion of Taiwan? I think we have like strategic ambiguity on it. We're not like saying what it is, and it may be that we're going to like decouple aspects of our economy from China. And what will China do as a response? Will they withhold sort of the goods that they're producing, right? Because they might say, well, no batteries for you, right? And so if all of Chinese battery production was withheld from the U.S. market, that could cause some problems. And so it is important that either the U.S. or our allies are kind of are able to, our allies, preferably in, not in East Asia where, they might be susceptible to Chinese embargoes or whatever, where we're able to sort of get them and have like full freedom of action despite like any threats that we might face from, sort of secondary effects from sort of a miscalculation to invade Taiwan. And I think also like if we kind of prepare for that and kind of have the supply chain in place, that makes the sort of initial miscalculation less likely, right? Like it makes war less likely if they don't think if the Chinese don't think that that's like a source of leverage that they can use against the U.S. to sort of force us to like accept a takeover of Taiwan.
And Ethan, I know that was kind of part of your, you were hearing that often as part of the motivation for people. It's like not just the manufacturing capacity, but the entire supply chain to really reduce the risk factors of like sole sourcing some of these things from places that our relationships may change to. I think the first time we met, you described yourself as wanting to start the Standard Oil of batteries. So I want to like give you a chance to sort of fully explain that analogy because I think it's a powerful one.
Yeah, I mean, so I guess the comparison is like I think batteries are sort of in the same place now that the early oil industry was in that oil started as this lighting fluid, so people used it in kerosene lamps. And then like it found use in cars and really exploded from there. And like a lot of the like lessons that you could draw from the oil industry are also applicable today. So there's all these crazy supply chain risks, whether geopolitical or just like supply demand mismatches. And so like the way this was typically solved or was solved in the oil industry was by vertically integrating. And so Standard Oil sort of went all the way up to drilling and producing their own oil and refining it and distributing it and marketing it. And so you see like some players already starting in the battery industry. So notably like CATL, it's a Chinese company that has about a third of the lithium-ion battery market today, has started to do some of this and just to basically like smooth out some of these challenges. It's so if you're producing cathodes yourself, or if you're doing lithium refining yourself, then you're not going to be subject to like crazy price swings and like limit your production that way. And so you can really like, so all of these like upstream, like hold up problems or like, supply chain shocks just end up manifesting at the cell level. Cause that's typically where, like automakers or consumer electronics or most customers are buying. And so, if you can have a steady stream of cells, then you can take huge percentages of the market just by having that available.
So Ouros wants to go. The final vision is sort of like all the way from raw materials to production and sales of finished cells.
Yep, ideally, yes.
Yeah, at all different kind of formats, right? Like anything from personal electronics up to cars, homes, grid batteries, contact lenses, which is a new one I didn't know about before.
Yeah, I mean, I think like there's certain like trade-offs with some of the battery chemistry. So we talked about LFP and NMC today, and they're good for different things. But if you can make a chemistry that's better on all metrics, on cost and energy density and power density, then there's no real reason that you would want to use other chemistries. And then I think like the raw materials question is sort of a little bit up in the air because mainly because of the recycling factor. So if you can, there'll obviously be mining going in the near future, but it's possible that at some point that just like stops being a thing at any sort of scale. And so yeah, that's one difference maybe between the battery industry and oil is you can't really reuse your petroleum. But yeah, that's like sort of
that's really the problem, isn't it?
Yeah, it is, right. But yeah, that's like sort of like the full scale vision is like, and even there's even like other underrated aspects of or like potential outcomes, right? So it's possible that in the future you would, batteries become so cheap that you just like, you don't end up buying them. You just like take a lease for your battery, or you have like a subscription plan for batteries, and then you send it back and then they refresh it and then, send it back, you buy it again or something, or lease it again.
And what's the sort of stage process for where we are now to sort of getting to that? Like what do you need from me, from Eli, from everybody listening to like get there in the near term? Because I think Eli's point was well made. Like this is let's hurry, like for a bunch of reasons, not just sequential, but like how good life gets on the other side of this. Like there's a lot to be gained by getting this thing commercialized and scaled and distributed as quickly as we can. I think there's a little life-changing technological improvement, and the sooner we can all sort of put our shoulders against it and make it happen, the better everybody's life is going to get.
Yeah, definitely. I mean, I think so for us specifically, we're fundraising now. That's taking up a lot of my time. We're going to try to bring on some guys I know that are sort of world class in their specialties that I think could really accelerate the development of a like commercial product, not just like lab scale sort of invention. And so, I think the sooner we can get to a product, the better. And definitely financing helps with that. I think, I think people being aware of like the potential in some of these applications and industries is always a good thing as well. And just like, there are certain aspects of like, dispelling uncertainty. So like, I think for the aerospace industry, like a lot of the sort of status quo or the where people are thinking today is like, they're not really sure what the future propulsion could be, because not all of them are really aware of like the potential high side of where batteries could go. And so there's a lot of like, hybrid or like sustainable petroleum or like hydrogen type systems being talked about. But I think, if they're presented with a good enough battery, I think it just makes the most sense for those types of systems as well. So, yeah, I think those are a few of the ways that we could move a little faster.
Nice. And that's partly why I was really excited to see Eli sort of bring his credibility and audience and syndicate to bear on this, because I think your words carry a lot of weight, Eli, and your where you choose to focus and the things that you choose to highlight as is important and impactful on the future. It really like helps bring a lot of attention to it. So there's a lot of scuttlebutt that happened once your syndicate started, and I thought it was really exciting, and it's just fun to find something that has this kind of potential to rally around.
Yeah, absolutely. Like what I like to invest in is stuff that will change the world if it works, and that's I like to go for the home runs, and that's exactly what I think this is. So if we can get 10x the battery density, that's just a completely different world, and it's super exciting to be along for even part of the ride.
Yeah. Yeah, that's how I feel too. Ethan, I appreciate you, picking this up and running with it. I feel like you're a man on a quest, and it's really fun to, be cheering for you and rooting for you alongside everybody else. And I hope that, the Army got a little bigger today with people understanding sort of what we're going after and what can happen if you accomplish what you think you can, what we all know you can.
Yeah, appreciate it.
Let's manifest.
Thank you. Yeah, and I really appreciate you guys, believing in the mission here, and we're gonna do you guys proud. So we're gonna get this to market as fast as possible.